Questions on page 81?
16.
Problem 16. And you got to be helping me. Angle 6 and angle 7 form a linear pair. While we're doing this, while I'm writing stuff up here, we will be taking some definitions tests here real soon. So something like linear pair, what's it tell us when you know two angles are a linear pair? They're equal to each other? They add up to 180. They are, what's the word that means add up to 180? Starts with an S. Boy, you better know all those definitions. Supplementary. So we got angle 6 and angle 7 are supplementary. Sorry, I lost my place here. Angle 6, angle 7 are supplementary. So we know that they add up to 180. Write that in. Twice the measure of angle 6 is 12 more than 4 times the measure of angle 7. Twice the measure of angle 6. So if I make angle 6x, and we're saying twice the measure of that is 12 more than 4 times the measure of angle 7. How am I going to do that?
7 is a different variable.
So we could do it as a different variable. So twice the measure of angle 6. What's that tell us?
X comes to
And we know that that equals what?
180. Well, yeah, what was it?
12 more than 4 times angle 7.
So 4y minus 12, I think? Or
More than.
plus, yeah.
Now what's the problem with that equation?
There's 2 variables.
It's 2 variables. It's not much fun when there's 2 variables, is it? What do you know about x plus y? Equals 180. So now we have 2 equations, 2 variables, and I'm sure whatever algebra teacher you had last year taught you about systems of equations. Probably didn't like them a whole lot. You probably liked them a little more than you like factoring, but not as much as just adding or subtracting or something like that. Could we solve this using systems of equations? The easiest way might be to get one of these variables by itself and use substitution. Anybody remember substitution? Which variable you want to get by itself? Which one do you like the best? X. So what do I do to get x by itself? Minus y. So what's x equal? Notice I did a little thing there. I stuck it in parentheses because using substitution, now wherever I see x, what am I going to put in its place? 180 minus y. So right here I'm going to stick in 180 minus y. Now I'm doing it this way just because this is the way I started to do it. Anybody have any idea that there's other ways to do this? Yeah, there's other ways. We could have done it with one variable, but Jacob said make it another variable, so that's the way I did it. What's good about this new equation here? It's only got one variable. So we solve it. Help me out. What's that give us?
360.
2 times the negative y. Now what? Good. Ignore all that. 360 equals, these canceled out, 6y plus 12. Then you said do what? Subtract 12 on both sides. Somebody help me out. What's 360 minus 12? What is it? 348? And that equals, the 12's over here canceled out, so what's still left on that side? Now what? Have your calculators out.
58.
Probably can't do that in your head. So y equals 58. So what's the measure of angle 7? 58 degrees. How can we find angle 6? 180 minus 58 is the easiest way. Are there other ways we could have done it? Yeah, we could have done it with one variable, just by letting this one be x, and letting this one be going through what all they told us, and putting in that representation of x in there. It would end up probably a little easier this way, because we'd have to take like half of it. It had to be like 180 minus x divided by 2, so on and so on. Does everybody remember systems of equations?
Sure.
We did substitution there. Anybody remember any of the other ways to solve with systems of equations?
You did the one where you did the weird minus stuff.
One where you do the weird line stuff.
You like. I don't know.
You graph it? Is that what you're talking about?
No. But yeah, you do that too.
So if we add two lines, look like this, and we're trying to solve, what are we trying to find? Where they intersect. So graphing was another way. Most of you probably didn't like this way a whole lot, probably didn't like this way a whole lot. The one that you probably did like was the elimination method. Good. Could we have used the elimination method on what we had? Yeah, what we'd had to do is get the y on this side. What do you got to do to move 4y over to this side? So it ends up being 2x minus 4y equals 180. No, equals 12, not 180. And then we had this one is x plus y equals 180. Does that look familiar to anybody? You line them up, and then you got to get rid of one of the variables. Pick a variable, which one you want to get rid of.
Weird minus stuff.
So what do we got to do to the second one to make these y's the opposite of each other? Multiply it by what? 4. We end up with 4x plus 4y equals, what is that, 720 maybe? This equation's sort of gone. Now we're just going to add them straight down. What's 2x and 4x give us? What's a negative 4y and a positive 4y give us? Cancel out. That was the whole purpose. Elimination. We eliminated the y's. 12 and 720. Somebody help me out. What's 732 divided by 6?
142.
Wow. That's what we got doing it the other way. Many different ways. Again, I use systems of equations, 2 different ways there to solve it. Other ways you could have done it just without using systems of equations. Next question. (26). Jameson, 26. It's right after 25. That's right before 24.
Wait, no.
Right before 27. Sorry. Boy, it's a pretty bad one. I'm trying to be a smart aleck and I screwed up, didn't I? 26. The collar guard. Shannon is designing a rectangular flag for the school's collar guard and is determining the angles at which to cut the fabric.
You said that wrong.
What did I say wrong? No, I didn't.
Collar.
I thought me and you were good for today.
Do us all better if you kick him out.
I agree.
Now you the draw.
I agree.
That's a beautiful file.
Ta-da!
Thanks for reacting with James B. Okay.
What do we know about angle 3 and angle 4, first of all?
Well, it's a rectangle, so all
They
the
should be
corners
equal.
are right.
So what kind of angles are 3 and 4 to each other? Starts with a C.
I said I agree with Henry.
Other C.
Complimentary.
Complementary.
I said I agree
Why
with
did you
Henry.
see?
What do we know about angle 5 and angle 6? Starts with an S. They're supplementary. I'm just writing this stuff down because we know it. What do we know about angle 2 and angle 1? They're complementary. Complementary two angles add up to 90, supplementary two angles add up to 180. Finally, she wants to measure angle 6. Better go back and read a little more of it. She wants the measure of angle 2 to be 3 times greater than angle 1. Angle 2 equals 3 times angle 1. Is this a good way to write this? Absolutely not. But is it going to help us?
Sure.
Hopefully. Am I confusing anybody by writing it that way? Is Zach going to think that this says 3 is less than 1 or something like that?
No.
I hope not. I'm just putting down notes so I don't have to keep reading.
3 is less than.
She thinks the measure of angle 3 and angle 4 should be equal. So angle 3, that's a 2. Angle 3 is equal to angle 4. Finally, she wants the measure of angle 6 to be half of angle 5. So angle 6 equals 1/2 of angle 5. Now let's see if we can figure anything out. So we want 3 and 4 to be equal. That's probably the easiest place to start. What'd you tell me about 3 and 4? So what's the measure of angle 3 got to be? 45 degrees. What's the measure of angle 4 have to be? 45 degrees. That's 2 of our answers. Let's see, so if that's 45, that's 45. She said angle 5 and angle 6, she wants angle 5, or angle 6 to be half of angle 5. What do we know about angle 6 and angle 5? They add up to 180. So if we want, instead of saying half of, what could we do?
6 is twice 5.
So we want 2 times angle 6 to equal angle 5.
I used ratio, so I divided it by 3 and then 2 it gives us 6 and 1 is 5.
So what Miranda's saying is you got 180 divided by 3, what's that give you? 60. So angle 5 is how much? 60. 2 times that is how much? So measure of angle 5 is 60 degrees. Measure of angle 6 is 120 degrees. They said angle 2, we want angle 2 to be 3 times as much as angle 1. What do we know about angle 2 and angle 1? They add up to 90. Again, if I'm doing this, could I set up angle 1, angle 2, and make one of them X, and then the other one whatever? I probably want to make angle 2 X actually this time. Because if angle 2 is X, what's angle 1? No, that'd be backwards. I was right the first time. If angle 1's X, what's angle 2? 3 times X. What are you going to do with those two? We said they add up to how much? I just confused everybody because I started throwing math in there, throwing algebra in there. So they add up to 90, so it'd just be X plus 3X equals 90. Now what Miranda said a second ago is if she used ratios and proportions, we know that this whole thing is 90, and we got 3 parts here, 1 part here, 3 parts, 1 part. So how many total parts do you have? 4. What are you going to do? 90 divided by what? Somebody help me out. What's 90 divided by 4? 22.5? 25. So 3 parts. What are we going to do to get 3 parts? Did I do that right?
No,
22.5. Keep lying to me.
Yeah.
22.5. 1 part is 22.5, so what's the measure of angle 1? I'm hoping. You guys are quiet now. It bothers me. It worries me.
22.5
Did I do something wrong?
No,
Is that right?
Not yet.
Measure of angle 2.
27, so 67.5.
What are we gonna do to that? Times it by 3. 67.5, you said?
Yep.
Hopefully it comes out right so that Zach, when he's waving the flag around, out there doing his little dance, he's gonna get up and show it to us. Sorry, Karen, I know you thought you were gonna see Zach dance, but I can't force him if he doesn't want to. Other questions? Whole bunch of math involved in that problem? Yeah, did you sort of think it through? We could have set it up and did all kinds of equations and everything. Sometimes it's better to just think something through. Other questions? So, 1? 1's probably the hardest one. In this book, I'm just getting used to it, same as you guys. 1's probably the hardest one on the whole page. I don't know why they do that, but a lot of the sections I've noticed have done this. We have a 2-angle problem. This one I'm going to set up using equations. If we let angle 1 be, normally we just let angle 1 be what? Some variable x. If you want to use a different variable, Zach wants to use z, go right ahead, it doesn't make any difference. The measure of these two angles, are supplementary. That's why Silas should be doing all the reading for me. What's supplementary mean? 180. Now they give us something strange here. So they didn't just explain what angle 2 was. They sort of messed it up and gave us something different. Well, if they're supplementary and angle 1's x, let's do this. If angle 1 was 50, what's angle 2?
$130.
130. If angle 1 was 70, what's angle 2?
110.
If angle 1 was 80, what's angle 2? What are you doing each time? Subtracting from 180. If angle 1 is x, what's angle 2? Is it just 180? What'd you do? Each time you did what? 180 minus whatever it was, right? So if it's x, you're going to do 180 minus what? If you know two angles are supplementary, one of them can be x and the other one's 180 minus x. Now they told us if we subtract these two, then we should get what? 35. Is that a feasible equation? Hopefully your algebra teacher taught you this last year. What happens when you distribute out this negative? What's it do to everything inside the parentheses? Changes the sign. So instead of positive 180, what's this? Instead of a negative x, what's it going to become? Like terms, what's x and x give us? 2x minus 180 equals 35. Somebody help me out with the calculator. Add 180 to both sides.
215.
215. Divide both sides by 2. What's x equal?
107.5.
So what's the measure of angle 1? How can we find angle 2?
180 minus 100.
We could do 180 minus 107.5. We could do, they said the difference in them is 35, so we could also take this and subtract off 35 either way. What do you come up with?
72.5.
Anybody have an easier way to do it? My first class did this. They went through and guessed. They said, okay, angle 1's 50, angle 2 is 130. Then they subtracted and got 80. Oh, that's not 35, so that won't work. Could you do it that way? Yeah, I don't care. your algebra teacher may have thrown a fit if you weren't showing your work or something, but if you come up with the answer, I don't care how you do it. Now, I shouldn't say that because I don't want Jameson looking back at Dominique's paper to get the answer. That's not being helpful.
You said it on.
That's why I just
You just said you can't look back.
restated what I said.
That was more.
Thank you, Dylan. Thank you, Dylan. Next question. 8. Problem 8, they tell us that line WX and line YZ intersect at point V, and they want them to be perpendicular. So I draw this line. What points am I going to put on this first line? W and X. And I draw another line. What points am I going to put on it? Y and Z. And it said they intersect at what point? Gotta be able to draw this stuff. And they want them to be perpendicular. So what's that tell me about this angle right here? It's a right angle. It's 90 degrees. So we have that picture. Now let's look. Angle WVY. That doesn't sound good. Angle WVY. That's this angle right here. What do we know about that angle? 90 degrees. And they told us that it was 4A plus 58. Is that right?
Mm-hmm.
Now, they put it in parentheses. Do those parentheses mean anything?
Nope.
They mean absolutely nothing. All they're doing is making sure that you know it's an angle, not a segment or anything else. So they mean nothing. But you just told me that this is 90. What equation can I set up then?
4A plus 58 equals 90.
Somebody solve that real quick while I go on and do the next problem, or the next part. Angle, measure of angle XVY, XVY, that's this angle. What do we know about that angle? How many degrees is it? The right angle, it's 90. And they told us that it was 2b minus 18. So what other equation can I set up? All of you stopped and solving the other one.
That one's 8.
So what other equation can I set up? 2b minus 18 equals 90. Anybody get A?
8.
8. That's one of our answers. I think they just wanted us to find A and B, right? Correct.
54 is the next one.
B is 54. Anybody else get that?
Yeah.
What's the measure of angle ZVW?
Z1.
ZVW.
What, it'd just be 2B minus 18, right?
Somebody said it. 90. What's the measure of angle, listen closely, angle WVX? 180. What's the measure of angle YVZ? 180, so on, so on, so on. What do you know about, no matter what in this picture, what do you know about this angle and this angle over here? They're always congruent. What kind of angles were those? Vertical angles. And what do we know about vertical angles? They're always congruent. Back to the definition test I said we're going to be taking real soon. Probably need to know that. Vertical angles are congruent. Other questions?
6. No, we have.
Doesn't matter if you want to do 6, we can do 6. 4. Angle Q and angle R are complementary. They're complementary. What's that tell us?
I have 90.
They add up to 90, so I'm just going to write that there so I don't forget it. Instead of putting angle 1 and angle 2, I'll put angle Q, angle R. 2-angle problem, doesn't matter what we let represent the angles. The measure of angle Q is 26 less than the measure of angle R. If we don't know angle Q, what are we going to put in its place? X. Now, we got to translate and put in for angle R. says it's 26 less than angle R. Measure of angle R. What's that tell us? What's the measure of angle R? We wrote it down over there. X. 26 just tells us right down 26, but what's less than tell us?
Negative. Minus.
Minus. So is it 26 minus X?
X minus 26.
Why?
It's 26 less than.
Anytime you do less than, not only is it minus, but what else do you have to do?
Flip it.
You gotta switch them around, you gotta flip it. So what am I gonna put over here for angle R?
X minus.
What equation can I set up?
X minus 26 equals X.
Just X minus 26 equals 90? Is that correct? You gotta add both angles, right? And this is a common mistake, so make sure you don't do this. You gotta add this angle and that angle. So what else do I need out here?
Add an X.
Add the X. What's X and X gives?
2X.
Somebody help me out. It's 90 plus 26.
116.
Divided by 2.
58.
58. So what's the measure of angle Q?
58.
58 degrees. How are we going to find angle R?
Add 26 to it.
We could plug in right here 58, or we could just subtract 58 from 90. What do you come up with? 32. Do me a favor, grab the notes up there.
I got one. You sent me 33.
Without your work, I don't know.
And on all these pages and notebook paper at home, I use like a whole thing of notebook paper. Just this is like literally, my mom, sorry, in my room, like.
Somebody do me a favor, once everybody has the notes, whoever's last getting the notes, turn the lights off for me. Oh, that was right.
Yeah, that's right. Got KD's. It's like stealing the notes.
It's like this more expensive than notes.
Yeah.
Wait, hold on.
The same thing.
That's $7.
No, mine's charging pass.
Alright, listen carefully. We're going to watch 2 videos. On those videos, it's going to help us fill out the first part of the notes, and we're going to rush through it. So, you don't have to fill out the notes right now. We'll do it after the videos, but listen closely to what they're saying in the video. And I apologize because the sound, you got to listen closely because the sound's not real good. I'm going to use a portrait plane and do it there.
There's a song?
Bro.
Ebersole talking too much when we should be playing the video instead of screwing around.
Teacher too.
Oh.
Teach you nothing. Again, listen closely. You can read along the bottom also. Thanks.
guess if you're a polygon, you're allowed to do that. Yeah, that bread is staying in the middle of the road. It's 56 minutes. Is that not whole?
I heard Washington.
And then immediately I'll have about. I mean, this was probably. And then immediately I thought about the same.
Did you guys hear Washington? It's not as good, but something. I don't like what my girl ever told me one day.
And this one, this guy says one word that's wrong all the way through the whole song, trying to figure out what it is.
Three angles, three sides, a quadrilateral is
It's in the chorus of the song.
four angles, four sides, a pentagon is a polygon with five angles, five sides, a hexagon is a polygon with six angles, six sides, a heptagon is a polygon with seven angles, seven sides. An octagon is a polygon with eight angles, eight sides. A nonagon is a polygon with nine angles, nine sides. A decagon is a polygon with 10 angles, 10 sides. Polygon is a shape with lines that connect. The number of sides tells us the name of the shape. A polygon is a shape with lines that connect. The number of sides tells us the name of the shape. Try a triangle up in the air. 1, 2, 3. Try a quadrilateral up in the air. 1, 2, 3, 4. Try a pentagon up in the air. 1, 2, 3, 4, 5. Try a hexagon up in the air. 1, 2, 3, 4, 5, 6. Try a heptagon up in the air. 1, 2, 3, 4, 5, 6, 7.
Ethan, you're not amused.
Heptagon up in the air.
You're not amused.
1, 2, 3, 4, 5, 6, 7, 8.
Sorry, this is not something I do very often.
Air. 1, 2, 3, 4, 5, 6, 7, 8, 9.
That cheese sound effect.
Try a decagon up in the air.
How do you think this works?
Which one? Oh no. Yeah, you haven't heard anything bad until you guys see it.
This is over the bad room.
Yeah, that song is here. This song is like here. Can you replay that?
How about no?
Okay, no, Gavin.
How about
Bathroom
that?
and one from the sixth class is like right there.
What?
That is the
bad
most
romance
boring
one from
I've
the
ever seen.
sixth class.
Oh no.
That was so
As I'm walking up here, turn the lights and stuff on. Anybody figure out in that first
The line is not.
or the second song what the word was that he was saying wrong?
He was saying lines that connect.
What should he be saying? There should be segments, all right? So hopefully he was teaching younger kids and not people your age because he's messing up.
Oh, I found it.
Find this on your notes. What makes something a polygon? We're going to put down 5 things here.
segments that connect.
Now, along with that, I'm going to say they connect, but they don't what?
They don't cross.
They don't cross. Can't cross. First one said that, right? Ignore that straight mark going up to there. Give me something else.
There's angles and vertices.
What do we know about the angles in the? Let's put a little
Same
more.
amount to the side.
All right, so let's go even a little farther. How many sides?
At least 3.
At least 3 sides. Number of sides, same as what? Same as number of angles. Sorry, started writing cursive there. Give me something else. First video, what'd they say?
I don't know. We couldn't hear it.
Yeah, I know, it was hard to understand.
couldn't hear
I didn't
anything.
get
I heard
I
a
didn't
video.
know nothing.
I heard Polygon, Washington, D.C.
Yeah.
So tell me what you know about a polygon then. I'll have to figure out a better way to show this maybe.
Same divisions. I
Sort.
heard divisions.
Throw out the play cartoons.
They're two-dimensional.
2-dimensional? Is that what you meant? I was trying to figure out what you
Yeah, I meant dimension.
So 2-dimensional? What else? The first one, you had to hear something in it because it said don't cross. That's what the first one told you, no crosses. What else did they say it couldn't have? No curves?
What?
So you got segments, that connect, don't cross, at least 3 sides, sides and angles, same number, 2-dimensional, no curves. What else? Nothing else? Is that everything? The first one said something else also.
Have to connect.
Have to connect, so the way I'm gonna put that, it's gotta be a closed figure. It's gotta be a closed figure. The other thing, you should have some space out here to the side. You're gonna write this down. Sides, name, we're gonna make a little chart. Shape's got 3 sides, what's its name? Triangle. It's got 4 sides. What's its name? Be careful. Quadrilateral. Now I'm going to actually switch to the next slide because it's all on there and you're just going to copy this chart. There's another name. Anybody know another name for quadrilateral? Don't say square, rectangle, any of those shapes.
4-sided shape.
Besides that,
4-sider.
I thought maybe, see,
Oh,
because
almost.
some of the new books, I thought maybe you guys were young enough, some of the new books aren't calling them quadrilaterals anymore. It has, a quadrilateral has, what's quad mean? 4 sides.
4 lateral.
Most of them are going, instead of going by the sides, they're doing the same thing as triangle.
Quad angle.
Quadrangle.
I don't like that.
Alright, so a lot of the new books are doing that. So 3-sided triangle, 4-sided quadrilateral or quadrangle. What's a 5-sided? Pentagon, 6-sided. Hexagon. Anybody know 7-sided?
Doesn't hear that?
Yeah, it's music on the slide.
I thought someone was playing that. I was like,
All of my old PowerPoints had music on them. Alright, but this year I had to make all new PowerPoints because we have a new book, so you guys sort of get ripped off because I haven't added music to them yet.
That's not.
What's a 7-sided?
You just skipped it.
What's a 7-sided? Heptagon. Now, new books also have changed the name of this. Anybody know a different name other than heptagon? Close.
Heptangle.
It's a septagon. Why do you think they made it a septagon?
Sounds like 7.
7. To make it easier to remember. What's 8-sided?
Octagon.
Octagon. 9-sided. Nonagon. 10-sided.
Decagon.
Decagon.
First period.
It got louder.
12-sided. Anybody have a guess?
I feel like I know it, but I don't remember.
I only do what?
Decahedron.
That's 10.
I know.
The only reason I put this on here, these are the ones, you have to know the names for these. Alright, these 10. Could we name every shape in the world using this kind of idea like we did here? Yeah. Do we really want to? No, then we'd have to have them all memorized. So decagon, or I'm sorry, 12-sided. What is the prefix that means 10? Deca. What's the prefix for 2?
Those. Look at those.
Do. Put those two together along with agon, and it's a do decagon.
Look at those.
Could we do the same thing for all the others? Yeah, but we don't want to. So down here at the bottom, if it's got n sides, however many sides, make up something for me.
8,426.
So if it's got that many sides, all we do to name it is write it that way. You just put a dash and then G-O-N.
That's my circle.
If you tried to draw it, it would, but if we used a computer or something, we could maybe make it ever something.
You should just have music playing all class.
I would, like a,
Are you
hear what I said? I had it on all my slides.
Not just the slide.
No, he means like it just keeps.
Oh,
playing.
just on the speakers?
Yeah.
I might do that.
But it has to be that music.
Now, the only bad thing is, if I do that, I can't have what I had when the music started playing and a whole bunch of people are off track.
We were confused on
Alright.
what's happening. We're not used to it.
Alright.
I heard it DJ.
Fill in what you need to fill in on this. The only bad thing is, a lot of times when I play music, something stupid comes on and then it's got to be shut off.
What kind of music do you like?
I don't listen to music a whole lot. You'll get to be my age one of these days, Jameson, and you won't have time to just sit around and listen to music.
I don't even.
No, Jameson, he will. Not. He
Well,
likes.
now we'll have bedtime.
No, I think Jameson, he won't have time. He'll be some big wig somewhere.
No, playtime is mommy baby.
Oh, Jameson will be so deaf you'll be able to hear from a mile away.
So a polygon is a closed plane figure. Perimeter. Does everybody know what perimeter is? How do I find the perimeter of that shape? Find the lengths of all the sides and add them all up. Please make sure, maybe you circle that or something. Just add up all the sides. Don't try to use any formulas to find perimeter of any polygon. You just find all the sides and add them all up. That's the easiest way. All those formulas for perimeter are silly. Alright?
Kick them to the curb.
Now, the one thing that you do need a formula for is a circle. What's D stand for here? Diameter. What's the diameter in a circle?
The fattest part to the
Distance
Distance, what do you mean?
from one end to the other.
It goes from one side through the center to the other side. That's a diameter. R is the radius. What's a radius? Middle to the edge, center to the edge. All right? Does anybody notice anything about these two formulas?
That looks
Times
almost
one
the
by
same.
They're exactly the same, except this one's got a D in it, this one's got 2 times R in it. They both got pi in it. Is there any difference in these two formulas? No, because we know that D, the diameter, equals what? 2 times the radius. So if you double the radius, you get a diameter. So same formula, just written 2 different ways. So if you're given a radius, you can just plug it in there and do the formula. If you're given the diameter, you can just plug it in there and do that formula. Doesn't matter, they're both the same thing. All your calculators should have a pi button on them. So try to find it and just make sure you're punching using that pi button to make everything a little easier on you. Again, this is the circumference of the circle. So all we're doing here, if I start walking right here, we're finding the distance it takes me to walk all the way around that circle.
Why would you be walking?
Don't you walk around the track?
Yeah, that's 4 laps is 1.
The other thing I want you to write down somewhere on here, for perimeter, the units for perimeter are always just regular units. So if you're dealing with feet, the units is just feet. If you're dealing with inches, the units are just inches. If you're dealing with meters, the units are just meters. Anybody have any idea why I say that? Because the next thing we're going to do is
Measure stuff.
angles, or I'm sorry, area. And when you're looking at area, what's the units always have to be in? Units squared. So like meters squared, feet squared, inches squared, so on, so on, so on. Fill in what you need to fill in on this one. We're going to add some other formulas to this because some of you might not like the formulas that I have. Zach just wants to use his own formulas that he made up for each one, right, Zach?
What the heck is that little squiggle mark?
That's how
That's an L.
That's not an L.
That's an E.
It's a
Blank.
That is an
L.
L.
Blank.
It's blank.
Squiggle
Like,
is.
I drew it as an E.
It's a cursive L.
So like,
How come I don't use a little L?
there's like a 1.
Cause that.
It looked like a 1, so you have to use the cursive one so you can tell the difference.
A cursive 1.
Now, and you don't want to use a capital letter because capital L means something completely different.
But not in my language.
For a square, area of a square is just the length. S stands for the length of any side, and you square it, which also means just S times S, so length of a side times itself. Most of you probably don't even like that formula. I would never ever use that formula because I know that all squares are what other shape? They're all rectangles. So could I just use area equals length times width? That might be better for a square. It might make it easier. Less formulas to remember. For a rectangle, when I look at this rectangle down here, which side's the length and which side's the width?
It doesn't really matter.
It makes no difference. All right? So don't care which one is which. It makes no difference. Which one's the base and which one's the height. Makes no difference. I don't care which of these two formulas, they both say the same thing. A lot of books are getting away from this formula because a lot of teachers don't want to have the conversation that I just had a few minutes ago with Dylan about what's that silly looking little letter. So they just use base and height instead of length and width. Another way to write the triangle formula. Instead of 1/2, what could we stick in there?
0.5.
So maybe change that on your paper. 0.5 times B times H. probably in the past had a teacher and they had you find the area of this rectangle, maybe back in like 3rd or 4th grade, and you didn't use the formula. What did you do? Count the little squares. Just count them all up, and that's what it is, and that's why it's square units, because you're seeing how many of these little squares fit inside there. For the triangle, come over here to the triangle on your paper there. I want you to draw this in. When you have the base and the height of the triangle is always going to be given. It's going to start at some vertex of the triangle. There's going to be this extra segment drawn in here, going to one of the sides of the triangle. What's that little box tell us? What's the little box tell us? Right angle. That's the height. The height's always going to be given in there somewhere. Unless it's a right triangle. If it's a right triangle, then this is the height. Just one of the sides of the triangle is the height. Wherever that little box sits at, whichever side it's touching, that's the base. So here in this right triangle, that side of the triangle right there would be the base. So you look for that little box, and that's going to tell you the base and the height. Again, if Jameson messes up and he puts this in as the base and that in as the height, is it going to matter? No, it doesn't make any difference to the formula. For a circle, you might want to rewrite the formula for a circle, because I know there's a lot of you saying, well, that's the same formula as we had on the other page. Is this the same?
No.
No. What's r squared mean?
Square.
R times r. You might want to rewrite it that way so you don't mess it up, because a lot of students think that that formula that we had a second ago, 2 times r times pi, is the same as that formula, and they're not the same. 2 times r isn't the same as r times r. So don't mess them up. Better mark that out. Somebody's going to think that it's the correct formula. Fill in what you need to fill in on this one. Name me a side in this triangle. TN. Segment TN. How could we find the length of segment TN?
Do you count with your finger?
Alright. If you have segments, you don't want to make any of this any harder than it has to be. If you have segments that are vertical or horizontal on a graph, just count. Don't make it harder by doing the distance formula. Ready?
1, 2, 3, 4, 5.
So how long is segment TN? 9. What's another segment in this picture that we could just count for? Segment TB, good. How long is it? 6. Everybody agree with that? What's the third side in this triangle? Can we just count for it?
No.
For this side, we have to use the distance formula. To do that, we'd have to find these coordinates, plug in there, find it. How would we, once we found that, how would we find the perimeter of that shape? Add all those up. How would we find the area, or could we find the area right now? What do we know about this angle right here? It's a right angle. So this right here, the 9 is the height. This side down here is the base. So we just do 0.5 times 9 times 6. That's going to give us the area. The 1/2 times base times height, right? Ethan looked at me like I was crazy when I said 0.5, but we switched it. Use either one. Everybody remember the distance formula? Hopefully. Pick me a side in this rectangle. We're going to do this. We're going to find the perimeter and area real quick. Pick me a side.
DC.
DC. Yep. So segment DC. If I'm finding the length of segment DC, what 2 points do I need to use?
1, 7, and 5, 3.
Those two, right? Distance formula, have your calculators out. That's an X, that's a Y, that's an X, that's a Y. I'm going to plug it in up here. You plug it into your calculator so you can help me get the answer. What's our X's this time?
1 and 5.
So 5 and 1. I'm going to turn around, put 5 and 1 because that makes it a little easier to do, right? What's my Y's?
7 and 3.
7 and 3. Let's make them, put them in that order.
Okay.
Somebody plug all that into your calculator. I think I got 32, the square root of 32. Am I right? And that comes out to be what? 5.6. Is that right? Or does it round up or something? Or
5.65.
so 5.7. So how long is this side right here in this rectangle?
5.7.
How long is this side over here?
5.7.
Do we have to go through and do the distance formula for it? No, they told us it was a rectangle. Pick me another side. BC. What's our X's for B and C? Negative 4 and 5. Do I want to put them in that way? Negative 4 minus 5. Could have put it in the other way. Might have made it a little easier. What's our Y's for B and C? 2 and 3. Right, Gavin? You guys made it harder on me this time.
I did. B and C.
Oh, it's supposed to be a negative 2, isn't it?
Oh, yep.
Messed me up.
Yep. Wait, whoa.
No?
Yeah, but, and the X is supposed to be 0.
You got me all messed up here.
Yeah, I screwed it up.
B and C. B, C. That's an X, that's a Y, that's an X, that's a Y.
5 minus 0.
5 minus 0. 3 minus a negative 2. Are we right now?
Yes.
Guess I should be paying more attention, shouldn't I?
Yeah.
Somebody punch all that into their calculator.
That's 7.07.
So you get square root of 50, is that? So 7.07, so we'll say 7.1, is that pretty close?
Sure.
Yes? So how long is this side? How long is this side? How are we gonna find the perimeter of this shape?
Add it up.
Tell me what that.
7.1, 7.1, 5.7,
25.42.
What?
25.6.
25.6?
You don't round up.
We didn't round up.
What did I do?
I don't know.
You might have hit an extra button there somewhere. Does everybody agree it's 25.6?
Yeah.
What's, and our units are just, they didn't tell us, so it's just regular units?
Very first one, 7.01.
How you gonna find the area of this rectangle?
Area of the rectangle.
What's the formula? Look back.
Area of the rectangle.
Base times height. What's the base this time? Does it really matter? 5.7. Somebody else said 7.1. Makes no difference. If we take the base to be 5.7, what's the height? 7.1.
40.47.
40.47. Anybody else get that?
I did.
What's different on our units this time?
Square.
Units squared. Very good. Is it all right for the perimeter to be less than the area? Does it matter? At some point, somebody's gonna come up and they're gonna say, well, but the area is less than the perimeter. It makes no difference. There's no set thing where one's gotta be bigger or smaller than the other. Circle, how are we gonna find the circumference of this circle? First, you gotta find what? We gotta use the distance formula and find the radius. Can we do this without me putting in all the x's and stuff? What's our x's this time? 6 and 4. Our y's? 8 and 3. Plug all that into your calculator. Anybody else get 29?
Yes.
What's the square root of 29?
5.4.
So how long is this radius right here? 5.4. Is that our answer?
10.8.
Circumference. How do we find the circumference? What's the formula?
The square of the radius.
Be careful. Wrong one. 2 times r times pi. That formula will work. So 2 times, what's the radius this time?
5.4.
5.4 times pi. Punch all that into your calculator.
33.9. Yeah.
What's our units if it's circumference?
Square.
Is it squared? We're just trying to find just the distance around it. Is that squared? No, it's just regular units. For area, it's square, right?
Yes.
How do we find the area of this? What's the formula?
Pi times radius squared.
So pi times r. What's r? Times 5.4 times 5.4. Somebody do all that for us. While somebody's doing that, what's our units gonna be?
Unit squared.
Units squared, because it's area. Remember, units squared, we're counting up how many of these little squares are inside that circle. Will it come out?
91.6.
91.6. Anybody else get that?
I did.
So it makes sense? Silas, did you count up all the little squares? Is there about 91 or 92 of them in there?
There's no way.
Do it real quick.
That looks like a lot.
You don't think there's 90 some in there?
No.
Really?
I think there is. Oh, no.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. About halfway through 47, does it look like there's probably about 90 in there?
Yeah.
Next one, find this. What's the first thing we gotta do on this?
Radius and coordinates.
We gotta find the coordinates. So help me out. Let's name these. Let's name that point A, this point B, and this point C, just so it makes it easier on us. Coordinates of A up here. -4, 5. How about B, down at the bottom right? 6. -5. How about C?
8, -4.
8, negative.
-8.
-8, -4. What do we gotta do to find the perimeter? We gotta use the distance formula, find all of them, right? So pick me a side.
AP.
Can we do this without me writing in all the X's and Y's and all that? Hopefully. Because there's quite a bit on this one, right? For A and B, what are our X's?
-4, 6.
So let's turn them around to make it a little easier, because it's gonna be hard enough the way it is. Oops, ignore that. That's gonna change to plus, right? 6 plus 4. What's our y's?
5 and negative.
5 and negative 5, change that to plus. That's 10. Anybody else get 200?
Yes.
What's the square root of 200? Why you got that calculator laying there? Square root of 200?
14.14.
So 14.1 we'll say. So this side over here is 14.1. Pick me another side.
AC.
X is for A and C.
-4, -8.
Change that to plus. Y is for A and C.
5 and -4.
Change that to plus. What I got? 16. 9. That's 81.
It's -4.
97. Anybody else get 97?
No.
No?
Because it's supposed to be -3, not -4.
Somebody told me wrong when we wrote it down, didn't we?
Good work, good work.
So -3, that's, goes here. So that's a 3 there. Let's see, then that's 64 plus 16, that'd be about, is that 80? Is that right? What's the square root of 80? 8.9?
4, 4, 2, 6.
That's So that side's 8.9. What else do we still have to find?
CB.
I got 14. What's our X's for C and B?
-8 and 6.
I'm gonna turn it around, is that all right? What's our Y's? Boy, I can't do this one in my head. 14. It's 14 times 14, 256, is that right? Yeah, 196. So 200? That all come out to 200?
Yeah.
What's the square root of 200? We just did it, didn't we? What's that tell you about those two sides? They're congruent. So this side and this side are congruent to each other. How are we gonna find the perimeter? Somebody add them all up for us, so I don't have to write it all down.
I got 37.4.
37.1,
Yep.
and it's just regular units. How are we gonna find the area? What do we need for area?
Base.
You need a height.
We need the base and the height, right? We know the base. Where's the base at? Which side's the base? So that's the base, but we need this height in here. How are we gonna find it? Use the distance formula again. We need the coordinates here. What is that? 1, 2, 3, 4, 5, 6, -6, 1. Do that real quick. -6 and +6 are our x's, so 6 minus a -6. We'll change to plus. Y is 1 and a -5, so 1 minus a -5, change that to plus. 12, 144 plus 36, 180.
Yes.
Somebody help me out with the square root of 180.
13.4.
13.4. Is that right? So now, our area is 0.5 times, what's the base?
8.9.
What's the height?
13.4.
Somebody do all that for us.
59.63.
Yes.
What's our units?
Squared.
Units squared. Thank you, slide. Too much work on that one problem, Zach? Sort of ridiculous, isn't it? Been nice if they made like this come straight over here, so we could have just counted or something, but we're jerks like that. Fill in what you need to fill in on this. We're gonna do this real quickly because we only got a couple more minutes. Equilateral. Equilateral tells you all sides are congruent. What shape did I put in that picture up there? Where'd that shape come from?
Home plate.
Home plate. Home plate on a softball or baseball field. And that's true.
No, Cooper, they're different.
That's true that home plate on a softball or baseball field is equilateral. All the sides of home plate are 10 inches. Stupid thing. Oh my. Equiangular. Instead of all the sides being congruent means all the angles are congruent. What shape do I have up here?
A rectangle.
Rectangle. What's a shape that's equilateral and equiangular and has 4 sides? Is that on? Is this not on your notes? See people looking there. A square would be, right? What's a shape? It's not on there. What's a shape that's a 4-sided shape that's equilateral but not equiangular? A rhombus. Good. If a shape is both, if all sides are congruent and all the angles are congruent, then it's called a regular polygon. Back to that definitions thing that I talked about a little while ago. Stuff you got to know. Fill in what you need to fill in on this. I don't think there's much, is it?
Yeah.
One word. Geometric model. Doing a geometric model just means that you're taking something in geometry and letting it represent something in real life. Like the floor. We said the floor is a what? A plane. That's all we're doing there. A geometric model. What can we do on this one? What could we make it into?
I start.
How many sides? 5, so we could make it a pentagon, and what would these be? So again, if they tell you something's equilateral, all the sides have to be congruent. So whatever the shape is, however many sides it has, if it's equilateral, they're all congruent. If it's equiangular, maybe we have some triangle. If it's equiangular, then all the angles are congruent. So you got to be careful, make sure you know equilateral sides are congruent, equiangular angles are congruent. If it's both of those, then it's called a regular polygon, and that means all the sides are congruent and all the angles are congruent. So if I'm looking at 4-sided figures, an equiangular quadrilateral is a rectangle because all the angles are the same but the sides aren't the same. An equilateral quadrilateral could be a rhombus because in a rhombus all the sides are congruent but all the angles aren't congruent. And then a regular quadrilateral would be a 4-sided figure where all the angles are the same and all the sides are the same, which would be a square. A stop sign, in real life, a stop sign, all the sides are congruent and all of these angles are congruent, so it's a regular octagon or a regular polygon. But again, with home plate, it's equilateral, all the sides are the same, but you'll notice that all these angles are not the same, so it's just equilateral, not equiangular. And same thing for a rectangle, it's equiangular because all the angles are the same, but this side and this side aren't the same, so it's not equilateral, so it's just equiangular. Again, a geometric model is a geometric figure that represents a real-life object. A good model shows all the important characteristics of the object. So in class, we use stuff like my pen. We could use to represent a line or a line segment. The ceiling we could use to represent a plane. Your desktop we could use to represent a plane, so on and so on. Drafters use two-dimensional geometric models to create technical drawings that show, whoever's looking at the next thing. If you're drawing something up, if you're drafting something, you're drawing it up so like plans to build a house or whatever, so that the person that looks at it next can see how to construct that. Scientists use two-dimensional models to record an object's general shape or mechanics. So, things like scientists might use for something like a shark, they might use a cylinder to sort of represent the body of a shark, just to get a general idea. You can use two-dimensional models to estimate the perimeter, circumference, area of objects. We'll talk more about that as the year goes along. Modeling in geometry it's just you saying, hey, this looks like this geometry or this geometric shape. So like on this starfish, if I do this, we got a pentagon. And if I add these on, well, I'm just adding on triangles. So I could model this starfish by using triangles and a pentagon. Bees make their honeycombs out of shapes that look like this, and that's a hexagon. You might look at maybe the pencil in your hand. The pencil's probably cut using a hexagon too. And the reason for that, the reason that bees use this, is because how they fit together. There's no wasted space. So if you see like a round pencil, if the company that's making round pencils, when they're cutting them all out of a piece of wood, they look like this. Well, they got these little spaces here where there's, if I could draw better, where there's wasted area. So that's why your pencil is a hexagon. That's why it's six-sided, and that's why bees make theirs hexagons, because they don't want any wasted space in between them here. They use up all the space that they possibly have. A tree, if we're just doing this two-dimensional figure of a tree, we could make the trunk of the tree a rectangle, and this part up here maybe a circle. If we're doing a three-dimensional tree, then this top part might be a sphere, and the bottom part here would be a cylinder. So that's just modeling, taking something in real life and turning it into some kind of geometrical shapes. So we're going to take this. You want to frame this marvelous poster to hang on your wall. How are you going to do it? Well, we're going to try to build a frame that goes around it somehow. Whatever that frame might look like. So we need wood. And the way we can figure out how much wood we need is by finding that distance, which is going to be the perimeter. And we're finding the perimeter of, the picture is a rectangle. So we're using that geometrical shape, a rectangle, to model so that we can figure this out. So all you're gonna do to find the perimeter of this rectangle is you just add up all the sides. Well, one of the sides is 1.5, the other side is 2.1, another side is 1.5, and the fourth side is 2.1. And we just add all those up, and we get, let's see, that's 3 plus 4.2, so 7.2, and our units were meters. So the perimeter is 7.2 meters. That means we need about 7.2 meters of wood. If we're making this frame out of wood, then we need that to put around this picture. And I know that confuses a lot of you because you're used to feet and inches when you're talking about something like that. Just remember that 1 meter is about 3 feet. So if we were gonna run to Lowe's and buy some boards, we just take 3 times 7.2 and we get 21.6. So we need about 21.6 feet. So if we were going out there and we were buying 8-foot boards, because that's normally what a board comes in, is about, a normal length is 8 foot long. Well, we'd need probably about 3 boards. So we'd need about 3 8-foot boards to be able to put the frame around this picture so you can hang it up on your wall. That's the assignment.